Times you seem to react. Good evening, everybody. I got the signal that we should start because the tram has arrived. What should I say? This is the last event of the first event. The last event because we will see hear what Julius von Bismarck has created, what he has done. We will hear what the scientist has got out of this. And one thing I'm really happy about is that both the scientist and the artist seem to have survived the collision, which is a good signal, okay? And as I said, this is the final lecture of the first event, and maybe of the first artist in residence, Julius von Bismarck. And this marks the formal end of the first pre-Ars Electronica Collide and at CERN artist residence. And the application for the next event is open. The deadline is, if I'm not mistaken, the 3rd of October. So if you feel encouraged after today to apply, do it. I don't think you have much chance, because I heard that there are already quite good candidates to follow. But I think it will be rather difficult to follow your footsteps, so we will see. Okay. And now I challenge Julius a bit, because I quote what he said, that the residency and his time at CERN has fundamentally changed the way he perceives the world. That's something. Which is the most valuable experience an artist can have. I'm sorry, that's your words. It was quoted in the press release. And tonight we are going to find out how and why Julius' worldview has changed forever. And we will have glimpses into his creative process inspired by the collisions between arts and science. But I'm also eager to hear and to learn from his inspirational partner, James Wells, the impact working with Julius has had on him. And I just heard that at least, can I quote that? At least sitting at 2 a.m. in the office, he was not disturbed by Julius. That's something. Okay. So I think the impact of Julius' residency has been felt everywhere, from being featured in leading science journals such as Nature. That's here, I have the proof here, and this is not a gun. I think Julius will tell you what that is, I guess, if you have a question. But to make it into Nature with this, it's not so bad. We have problems to make it into Nature with our scientific articles. So we have to talk how you made it, okay? Nature, New Scientist, General International Press, from Brazil to India to Australia, across Europe. And I think that shows that we have a good program. We have filled it with good candidates, I have the impression. And we will continue along these lines. And I hope after this evening we will really see how to continue and what it brings, not only to arts, but also to science. Because that's the reason why we do it. We want to inspire our artist friends, but we want also that our scientists are inspired by the arts. And I hope you bring that over this evening. So no pressure, but I hope you will bring that over. Okay, so I don't want to make more words on that. I just want to announce that in roughly 1 hour, I unfortunately have to leave because I have to catch a plane, because there are some other mundane things like money and so I have to fly off to another place to make sure that we continue like this. And I will miss at least the banquet. Okay. Thank you very much. Have a very nice evening and enjoy the discussion with the two. And now I hand over not to Horst Stöck. Horst? Gerd. I will now hand over to Horst from Ars Electronica, who will also say a few words, because we do it together. Okay, thank you very much.
Welcome, everybody. Before we discuss this year's results of the residency of the pre-Ars Electronica Collide at CERN residency program. I want to thank the Director General, Rolf Heuer, and the CERN's Cultural Board for making this collaboration possible. And I want to thank in special Ariane Köck for creating this collaboration between CERN and the Ars Electronica with us. We are here to discuss, to celebrate the outcome, the first outcome of this residency program. But before that, I would like to talk about the program itself a bit. The Ars Electronica is an institution focusing on the nexus of art, technology, and society since 1979 already. Takes this residency as a key approach in the residency network program of the Ars Electronica. It's a key aspect inside that network. This residency program is a major step towards a sustainable experiment in colliding concepts of art and science. The important question for the Ars Electronica is, are there methods, strategies, mechanisms in this intersection or nexus of art and science that are especially conductive for an artistic or scientific process or outcome, which is of equal relevance for both disciplines, the scientific and the artistic discipline? And if so, what are these mechanisms? Other than using art for pure beautification of a scientific outcome, and also other than using scientific outcome and putting it into a different artistic context, can we generate a fruitful collision of concepts beneficial for both sides? If science is about understanding our world, if science is about generating knowledge about our world, then art may be about experiencing our world. Art's generating experiences. Can we experience science? Newton's apple may be the most powerful experience in the science history, probably. The question is, are we, art and science together, capable of generating an experience as powerful and sustainable as this apple? Be it by going through a process of transdisciplinary collaboration, as we had it here, or be it by experiencing science. To answer these questions, we need to generate many collisions and try to understand each single step towards the outcome of those. Observing the collisions to learn. Is it possible to enrich our existing tool sets inside the scientific world, inside the artistic world, with some of these new methods, strategies, or mechanisms that we encounter and discover here? I couldn't think of any better place to do these collisions as here in CERN, and I couldn't think of any better international network of artists as the one of the Ars Electronica. I want to thank you both, Julius and James, for your efforts in colliding the concepts of art and science in the first pre-Ars Electronica Collide at CERN residency. Thanks a lot.
So I'm just going to quickly say, how did it all begin? And in a way, I think creativity starts when you're a child. I think all of us are born like children. When we're children, we experiment and test gravity and boundaries, and that is the way we are artists and scientists when we're young, and really colliding those kind of experiences and going into the unknown make us what we are. So the idea for CERN and this Collide at CERN experiment is very much to do with dropping an artist into the unknown, dropping scientists with an unknown artist, and then seeing what encounters happen. Because it's only when we encounter the other, the different, the strange, that we learn, we grow, we create, we play. So this also began in another way. Not only in all of us is there this creativity, but it began in 2009 when I was invited here to do a feasibility study for setting up an artist residency program. And I didn't know what I would discover here. And after 3 months, I discovered that CERN is like a storehouse of ideas, of incredible ideas, which take you into dimensions you never dreamt of. So when a scientist says, you know, this looks really solid, but actually it isn't, it's all 90% full of holes, then you can imagine as an artist, your mind just jumps. And from that came the idea of Collide at CERN as a place for a springboard of the imagination for artists, not to illustrate the science, but somewhere where they can jump and play, and where the scientists who they're matched with can jump and play with the artists as well, and then discover new possibilities, new ways of thinking, new ways of being. So we're very lucky in having, as our cultural international partners, Ars Electronica, and I thank Horst very much for working with me on constructing Pries Ars Electronica Collide at CERN, which is 2 months at CERN, ideas generation, and then a month at Ars Electronica for installation and production. We also have another strand, which is Collide at CERN Geneva, and we've had a choreographer in residence who will be speaking on November the 6th. And I would also like to thank the private donors who make this whole program possible, as well as those other partners I just described, because we're trying to do something very different here. We're not instrumentalizing the science by using the artist to illustrate that. As I said, we're trying to create these kind of creative collisions which take us all further and farther. But the most important thing now is really to hand over to Julius and see the ideas which have been generated. And what I would say is it's all about ideas generation, not the product, but the generation of ideas and the imagination. And that's what's so important. Anyway, so Julius von Bismarck, first Pries Ars Electronica Collide at CERN artist. Over to you.
Hello. I will try to explain a little bit of my experiences here, but of course it's hard to decide what to focus on because I just have a couple of minutes, and I also want to talk about the piece that I made while I was here and after I was here, and also about the pieces that I will make, and also how it changed me, and also it's too many things. And I'm also not good in putting a lot of things in a little number of words, but let's see how it goes. I first heard about CERN as a teenager or as a child, and I thought it's on a big mountain. I always thought it's just one of these tunnels with a big door that you see sometimes in Switzerland, and everything is underneath a big mountain. And then the next times I heard about it was when I started to read scientific magazines in order to get inspiration for my artistic practice. And so I'm using the results here since quite some time for my inspiration. Just because I was interested in it, and for me it's just more interesting to read a scientific magazine than an art magazine. I don't know why, but that's my source of inspiration. And the next time I then heard more about CERN was when we invited Otto Rössler. He's a German scientist, or he was a German scientist. Now he's kind of not accepted as a scientist anymore from most scientists. He was one of the guys that believed that the experiments here will lead to the end of the world. And but he is friend of some really interesting other guys that we were knowing. For example, Peter Weibel, an Austrian artist, and also one of my favorite professors in Berlin. So we thought, okay, let's invite him and hear his story. And then we listened to him, and I never believed in that part that the world is going to end. And also he merged everything. He didn't just talk about his scientific work, and he did some respected scientific work. He invented a chaos attractor that is received, and but now he's putting everything together with esoteric things, with religion, with so many things, and he made such an amazing mix. But it was just not acceptable as science, because science doesn't have the freedom to do this mix of everything. And so it was really inspiring for us. And then at the end of the year, there was a Rundgang that's in the art school. Every end of the year you have this exhibition where the school is opening and inviting people to come, and normally thousands of people are coming to have a look at the young talents and going through the classrooms and looking at the art. And instead of exhibiting our art, we exhibited Otto Rössler's speech. So we had him sitting in our classroom for 4 days, talking 6 hours, I think, every day. And he was, I have pictures of it. Here. And he was using this OH projector, and while he was talking, he was drawing all the time. And then we exhibited all his drawings. You can. These are some examples, and I just told this because this really got me really interested in what happened here, and I really focused on reading articles about the work here, and I also discussed with him hours and hours about physics and about philosophical things, and maybe it's hard to understand these without his speech. But there's tons of information in them, like lots of names that he's talking half an hour and then just writing down one name. And and here you can see Higgs boson CERN. So that was the next step, getting closer to this place. So I'm really thankful to him to inspire me more to think in this direction. And I don't know, maybe some people here don't like him because he made some maybe negative press, but I think he created good controversial discussions, and I think no one really believed that the world is going to end, but whatever. That's not my interest anyway. And then I heard that this residency is announced, and I thought, wow, that's the best thing that can happen, but I won't get in anyway, but I at least have to try. And somehow I was lucky, and then it was very fast, and Ariane picked me up at the airport for the first visit, and then the collision was already happening, and I must say, I'm sometimes quite shy, and I think also a lot of the scientists here are a little shy. And the collision was actually made by Ariane because she somehow was the technician of the collision. She took me and put me in front of the scientists and arranged all the meetings and spoke with the scientists and spoke with me, so everything works out. So without her, I think I would have been lost. But thanks to her, I had, like, in the first 3 days, like, I don't know, 20 meetings, or I can't remember how many. But after every meeting, I felt so different than before. And I was always feeling like, okay, now I'm getting one step deeper, one step further. And my head was full of ideas. And now I think I have to go maybe on. I could not, like, talk more and more and more about my experiences here. But I also want to get to the things that I thought of, that I thought about, and that I'm planning to do. And one of the first ideas that I had was, after speaking with some people about gravity, how can I make a piece that exhibits gravity in a different way. I did already pieces with gravity, and one of them, one idea was to make a dent in the Lake of Geneva, just this slightly dent, that would, depending on who is seeing the dent, would, I don't know how it can be interpreted, but I think most people somehow have to start to think about gravity when they see a dent in the lake, because the spheric, almost flat-looking or perfectly flat-looking surface of a lake is just a result of the homogenic gravitational field. And when there's a dent, there must be something wrong with that field. And let me see. That's not the slightly dent, but just to give you an answer, that would be a deep hole. But I just want, like, if that's 100, I want 1% of that. Just a slightly little dent that you cannot see in the beginning, but after walking around, you see something might be wrong with the field here. And because gravity is something we take for granted. And it's especially my interest is to change how people perceive things that they take for granted, that they never thought about. And that's also why I'm so interested in the place here, because CERN is a place where science is made, or that is changing things that were most people thought before that there will never be change. Like, it's kind of, for me, it's a reality machine. It's creating reality. Every new scientific result is changing how we see the world, so it's changing our reality, because how we see the world is the reality. So every bit more that is discovered here is changing reality and changing the truth. So, and this is happening here much more than in other places. So for me, this is the place on Earth where most truth and reality is generated. And so people are adding here something to the world that will change the world afterwards. And that's what I'm also trying to do with my art. I'm trying to add a piece of art to the world that will change the world slightly afterwards. And the next thing I worked on is Tesseract. This one crashed. I have to restart it. There we go. And this is another field I'm really interested in. It's dimensions. and what is happening if we try to think about more than 3 spatial dimensions. And for a lot of scientists here, that's everyday life. They work with equations, they work with spaces that have more than 3 dimensions. For normal people, it's really hard to get an idea about it. What we see here is a 4-dimensional cube, a tesseract or a hypercube, and it's rotating right now in the 4th dimension. And we see a 2-dimensional projection of a 3-dimensional projection of a 4-dimensional shape that's turning. Now it looks like it's turning in 3 dimensions, but actually that's just our view angle, because from this view angle it looks like it's rotating in 3 dimensions, but actually it's rotating in 4 dimensions. If I move my mouse, I will change the view angle, and then you will slowly see that actually it's rotating in a totally different way than you expect. But it's just changing the view angle. It was just a slightly change. And now you already see something like turning inside out. Now you can see it maybe better. Or like this. So a thing that is turning in 4 dimension, the projection of it in 3 dimension is somehow looking like it's turning inside out. That's a typical effect that is also happening on other shapes. And I want to build this shape as a real shape. So it will be, now we have a 2-dimensional projection of a 3-dimensional, of a 4-dimensional thing. And I want to make it 3-dimensional. So we just have one projection step and make that move and make it turning inside out. And maybe it should be really big. So a human could stand inside and it could rotate around the person. But yeah, this is not the work that I realized. The work that I realized is this work. It's called Versuch unter Kreisen. I don't have a German title, English title yet, but it's also not so important. It's inspired by movement, by circular movement. I looked at circular moving things. I looked at 2 moving things. I looked at 3 moving things. And I looked at 4 moving things. And I looked at linear moving things. I looked at circular moving things. And every time my brain had a different effect. If you look at multiple moving things, your brain is trying to find, or your eye, or somewhere in between your eye and your brain, you're trying to find a law describing the relationship between the different moving things. So if you have this, the law is quite easy. They're just both doing the same. If you have this, it's also easy. And your eye is doing that automatically. It's not an intellectual thing that you have to do. You don't need education for that. It's automatic. And I wanted to put that part of the brain to a little stress and make a sculpture where your brain is always in between finding a law to describe that nature that you look at and then losing it again. Always this stage in between is what I'm interested in. Also with these sculptures that are these between 3 and 4 dimensions, you're always in between understanding the 4th dimension a bit and then losing it again. And this spot is exactly what I'm interested in. Like the edge of our brain where we run against the boundary of our perception. And so this is just one of the lights. These are 4. now it's maybe easy to see the relationship. It's maybe some elastic thing. That's what my eye is telling me, that somehow it's elastic, but there's no connection between the lights. It's 4 normal industrial hanging lights, and to each light I attached motors that are able to accelerate it on each circle a tiny bit, so it's just enough energy to keep the light in circular motion. And each light has a slightly different frequency, because the frequency is set by the length of the cable on a pendulum. If you make the cable longer, it's slower. If you make it shorter, it's faster. So each cable has a difference between like 5 centimeters. The first one is the shortest, the last one is the longest, and then they are just turning in their own frequency. And because I chose the frequencies, the length of the cables carefully in a way that every 6.5 minutes the first pendulum is making 75 circles, the second one is making 76 circles, the third one 77, and the fourth one 78. And they all started in the same phase, so every 6.5 minutes they have the same phase and they look like if they are connected to each other. But it's just the numbers that I chose. And in between they have odd numbers, because 75, 76, 77, and 78 don't fit in each other. So in between it's odd, and odd looks like chaos. And so you always have this shift between chaos and order, and in between you have this elastic thing. And yeah, so now you have like a more chaotic situation. Yeah, that's almost at the spot where they all have the same phase, so that's close to the 6.5 minutes circle. Yeah, of course, this whole search for a law and losing it again is inspired from here and from all the articles I wrote. I was reading about science. I think it's not just for this place; it's also for other things where laws are established and then broken again, or you need more laws to make the first law work, and I think it works for the whole life. You always find something and you lose it again. And if you look, yeah, it's this that's momentum that, yeah, was the inspiration for this. Yeah, if you enter the building on one way, that's the first thing you see. That's after 32 circles. And do I still have some minutes? 5 minutes? Okay, I will try to connect now to the pendulums because they're controllable via the internet live. I don't know if there are some people in the audience that are interested in such technical stuff, but maybe, I don't know. Let me see. Now it should connect. Hello. Okay, one more try. Okay, the internet seems to be too slow at the moment.
That's not possible at CERN.
Maybe there's too many people in the audience that are bored and checking emails right now because I'm on the same wireless. Yeah, okay, it's just not opening the VNC connection. Whatever. What I wanted to show you is the control software that I can remote control from here. And because it was quite complicated to actually control these 4 pendulums so precise that they look really as if they are one thing. Because some centimeters, some degrees off, or a little shorter radius would look like totally wrong. And also sometimes they're not making circles, they're making oval. And so I spent together with Martin, who helped me with the technical setup, a month staring at a pendulum and trying to control it. And then I was remembered to speaking to experimentalists here and engineers that are trying to focus the beam. And it's also a circular motion, and also the software looks a bit like it, so that's why I wanted to show it. Or there, and you have these circular motions, and you're trying to form something that is in a circular motion, but in the circular motion, there are other frequencies overlaying, and yeah, that was just a thing that we could have seen in the software. I'm sorry for that. And yeah. Now I'm a bit confused with my... yeah, so what can I say in the end? I cannot really say what this all means for me, because I'm in the beginning of my work. I'm 28 now, and I cannot really... I don't feel old enough to really say what the outcome is, because I feel the outcome is still happening. It will happen. It's in the future. The thing that I just showed you is an early outcome, but I have a book full of ideas that I'm hoping to realize. And as you already described it, my way I see the world changed. When I look at a star, when I look at a thing, at a piece of metal, I see it now differently than before. And the way I see the world is the source of how I build things. So my way of doing art now, of course, changed a lot because the way I see the world changed. And I think that's, for me, that was the biggest goal, and that's the most important thing why a residency like this should happen, because there's a lack of information exchange between art and science, also between other fields. I think it's not just art and science, it's also business and politics. I think there should also be more exchange. And because how can an artist make relevant art if he doesn't know anything about relevant science? How can a politician do relevant politics if he doesn't know anything about science or art? And it works for all the fields. So this is a really important thing, and now I feel I'm able to do more relevant arts than I was half a year ago. And yeah, thank you very much to all of the people that made this happen, and especially to Ariane. Thank you very much.
Right, we're going to have a short discussion now, and you're going to learn a bit from James Wells, who is the inspiration partner. It'll be a short discussion, then we'll open questions to the floor, and then you'll be able to have some refreshments at the end and come up and talk to Horst, James, Julius, and myself. Anyway, so we're just going to go up on stage now. So Horst, James, Julius. So I know Rolf has got a plane to catch, so I'm going to quickly ask the question to James. So what did you get out of this encounter with Julius? We've heard about what Julius got out of it, but what did you get out of this encounter? You were his inspiration partner for 2 months. I did some speed dating, basically. I put those two together because I thought psychologically and intellectually and imaginatively they were very, very suited. And they just had this amazing interchange when they met. So they just were, you could tell something would happen. But what did you actually get out of it?
I got several things out of it. One of them that I learned very quickly on, I got disabused of a false concept in the art community, and I think artists have similar misconceptions of scientists. So let me tell you what an artist might think a scientist does. They sit under a tree, and they wait for an apple to fall on their head, and they have this brilliant inspiration, and then suddenly they revolutionize the world of science. And it doesn't happen that way. Scientists work really, really hard, and they do a lot of so-called drudgery. And the inspiration comes after a lot of sweat and effort and cooperation and communication. And a scientist might have inspiration that Michelangelo woke up one morning and said, oh, there's a big piece of marble in front of me. I think I'll just make a statue. And then by lunchtime, he's got something fantastic. And it just doesn't work that way. And I've learned with Julius as somebody who's clearly at the top of his field in art, and the way he approached his work was very nice to see by those of us who have had the opportunity to see it. It's tremendous care, tremendous dedication, knowing what you're doing, hard work. You have to be talented, which he's extraordinarily talented, but you also have to put the work in. And I think when scientists see that we're not the only ones who have to do that everybody who's is the top of their field has to do that, it's refreshing. So that's something we have in common that I learned that was very very nice. Something that I learned that was a bit different between the arts and science community. It was quite inspiring. My discussions with Julius, he would say things like, I want to take a group of pigeons and color them strange colors and have them fly around and see what happens. And my first thought is, okay, that's illegal. That's, what do the pigeons think? He says he wants to take the lake and put a big depression in the lake. And I say, oh, what are the boats going to do? What are the people who are swimming out there going to do? And it's this approach of a daring approach to how he views the world. And that I've noticed that a lot of artists have. I was at Linz, Austria at Ars Electronica Festival recently that Horst is in charge of. And I saw it in spades there. Just tremendous daring, tremendous openness and of ideas. And the first thought to an artist is not, how can we do this? The first thought to an artist is, this is what I want to do. And then later, maybe we'll discuss things like Swiss law and international conventions. So Julius, he just mentioned that he's 28. And many PhDs in physics graduate at age 28. And what they're used to is being somewhat confined in what they do. They're sort of, at the beginning of your PhD in physics, you don't know what you're talking about. You're very lost. It's very difficult. It's a cumulative subject. And you more or less need to be told what to do. And that can snuff out the daring and creative impulse in students. And so one of these collisions that I really hope made a difference to people at CERN with these newly minted PhDs and students is to seeing somebody 28, around their age, who said first, what do I want to do? And then second, how do I do it? And what do I need to do? And if you don't mind, I'll tell you one story about when I was a newly minted PhD, if you don't mind. I went off to Stanford after I graduated, and for one reason or another, we had lots of talks on glue balls over the course of a couple of months. Now, a glue ball is a very special particle in particle physics. It hasn't been found yet. And it's, in my view, it's not nearly as fundamentally interesting as Higgs boson, but nevertheless, lots of people were interested in looking for a glue ball. And that's when the gluons, the things that make a proton and neutron stick together, the quarks and a proton and neutron stick together, all on their own make a state, make a particle, without quarks. So it's a very special kind of object. And this guy came and gave us a long review talk. He was an expert, and he was devoting his life to it. And we don't have evidence for it yet. It's confusing. And then at the end of this talk, somebody said, well, why, if the President of the United States said, I will devote, it's my number one priority, I will devote every resource I possibly have to trying to find the glue ball, what would you advise and what would you do? And he just paused for a long time and said, I don't know. I'll have to think about that. If he were in the CERN cafeteria with Julius, he would have thought about it before that talk. And I think this is the kind of inspiration that is really helpful from the art community.
So basically, CERN better watch out now from James and expect the unexpected from you.
I'm not speaking.
So, as part of the residency, Julius also did interventions in the laboratory, very deliberate interventions, which were ways of interrupting the science, interrupting the way scientists look at the world, and giving them new ways of looking at the spaces and dimensions they were in. I wondered if you could describe one of your 3 interventions and what the purpose of it was.
Yeah, there was not enough time to do it in the talk. I actually wanted to also speak about that. Now I don't know which one to choose.
Looking them up.
So one was we met with a couple of scientists. Actually, we just thought about a couple, but then there was quite a lot. So we squeezed in a dark space where you couldn't see anything. And we talked about things you cannot see. And in CERN, there are a lot of things you cannot see. And for me as an artist, it's really interesting how people describe things that they cannot see. So unvisual things that are really, really important for us. And so that was one thing compressed into a couple of words. Then the other thing was art lesson. I thought, okay, every scientist I speak to is giving me a crash course in physics, and I wanted to strike back. And so I made a crash course in art, and I tried to compress my whole art education that I had in the last years into like 20 minutes, or into 1 hour actually. And so I made 5 minutes art history, and then I ask everyone for an idea what art piece they would do in order to afterwards make a critique, because critique is what normally at art school is happening all day long. And so every scientist came up with an idea of an art piece they would do. And in the end, in between, we made some strange walk. We acted like particles on the Parkplatz of CERN. And then everyone talked about his idea, and we criticized it together in the group. And not really surprisingly, there were really great ideas. I was hoping for that, and I wasn't disappointed. And especially the idea of James struck me, because I had a quite similar idea before, but his idea was in some sense even better. So I fell in love with your version of that idea. And so I hope that we can make it real together. So it would be a collaboration. I actually have some news we have to talk about later about it. So that was for me a really fun and successful thing. I don't know how it was for the others. Maybe also embarrassing, like to be like a school child. But also sometimes it's for me embarrassing to I feel sometimes a little stupid here at CERN, because there's so many smart people that know so much about physics, and I'm, of course, never able to understand, and I always need to get these simplified versions of what people really do. But scientists here are really good in picking a good version of what they do that I'm just able to understand. So, yes, thank you very much for that. And now, as I mentioned too, so I also have to mention the third one. I'm sorry.
Okay.
I recorded sound in the cafeteria, I was reading a book from Heisenberg where he described his time after the war, where he was caught in a prison, it was house arrest. He was in with all the other German scientists that were working on sensitive things, and they were recorded, of course, what they were talking about, and they were imprisoned there while the atomic bomb fell, and what they talked was recorded and written down, but they were aware of that. And this really inspired me. And so I recorded sound in the cafeteria with the help of a sound engineer, Daniel. I think he's here somewhere. Yeah, there. Thank you very much. And I recorded on different channels to recreate the sound sphere of the cafeteria later. I won't do it soon, because I think it's only interesting with a larger time gap in between. So people can hear maybe in 10 years the soundscape of the cafeteria and CERN while the Higgs was discovered.
So, Horst, what is your response to this kind of collision which you're hearing about, the interchanges which have happened and on different levels between James and the science community here?
Well, that's actually more than I could hope for. Hearing James talking about the capabilities of the artistic approach in probably even education and research, at least on a PhD level, that's really something interesting to hear. And a concept that we should follow up. And also the statement from Julius saying that sustainably change of his approach as an artist that has been caused by this residency here. What I would like to think about is actually creating a project and doing vice versa, getting a scientist out of CERN into an art community like the Ars Electronica and see what comes out that way. That would be also a very, very interesting approach.
We discussed that at lunchtime and thought we need to complete the circle, basically, because this experiment goes one way, but we need to complete the circle, because it's been really fascinating watching Julius inside a science community. But the other way around, it will be totally fascinating too. Yeah.
Definitely.
Yes. This would be a good time to open up questions to the floor, so you can ask us anything now. You have us all here. So if you want to ask a question, just raise your hands, and we'll take some questions for 10 minutes and then have refreshments. Okay. Shoot. Well, that might be patented, IP.
Julius, IP? Come on, we are
I
free
think we can
here.
talk about it. Do you want to describe it?
We have open access here, so at least you could indicate your idea. Otherwise, we have to talk privately.
Yeah, we might have to talk privately.
Yeah, we might have to do it privately. That would be a ...
Yeah.
But a top international gallery is very, very interested on this private idea.
It's probably best not to talk about it at the moment, but we'd be happy to to do it. Yeah.
An interesting thing which happened at the end of the residency is that Julius was doing, you were working really extraordinary office hours, like working 10 till probably 4 in the morning. And then but at the end of the residency, you said to me, I just had to go off and create and make something. So when you went back to Berlin, ...
Yeah, I just went crazy in my studio and building things with my hand, because that totally didn't happen here at all. And after 3 months of brain work, it was so refreshing to work with my hands. I created 4 horns, like loudspeakers that were supposed to amplify the voices of a sparrow, like these small birds. Spatzenverstärker is the title of the work. It's kind of a pretty silly work, but I could build these horns, and that made me so happy to just. So that's also part of why I am an artist, because I need this balance between brain work and the work with my hands. So I love to also be in my studio.
If you betted a scientist and an art, you would have to have a chalkboard. It would be the same.
Okay. Anyone else who wants to ask something of us, or do you want to ask something privately? It looks like, okay, what we'll do is... Oh, there's a hand suddenly sprung up right now.
Artists work as lonely wolves. They are on their own in the corner. Scientists are in groups. They work as a team. Is this a cliché, or did you realize while you were talking together, colliding?
No, I think it's also for you. I love to work in a team. Actually, sometimes I like to think alone about things, but I actually don't want to be alone. I'm either on the last work I did where we painted the pigeons. I worked together with another artist, and if you wanted to look it up, we painted them in Venice and in Copenhagen with painted pigeons. You can maybe find it online. And yes, it's so amazing to work together with another person, because you don't get stressed by yourself. I don't know. It's for me, working with other people is really important. But in a large team, it's getting difficult with art, because then you have to make so much compromises, and you can always see that in a work when there are a lot of compromises. And so you really need to really fall in love with the same idea, and you really need to have the same opinion about it, and then it's really fun to work together. But I think I couldn't work in a team with more than 3 people. That wouldn't work. But aren't you also working alone quite a lot?
No, the scientist works both alone and jointly. So there's a lot of time you spend working yourself to work things out, and then you come together with collaborators and compare notes and iron it out. And an experimental collaboration here at CERN is very large, the experimental collaborations, but it's made up of lots of individuals working very hard on their own and in small groups and then in bigger groups. There's a coordinated effort from small to big with different goals at each level of hierarchy. And I'm a theoretical physicist, so I don't work, I don't have a hierarchy that extends too much higher, but I like to work with people as well. It's, there's so much research that shows that competent people, multiple competent people working together is superior to one genius. And I think we've seen evidence of that at CERN. Maybe it's we've really seen a lot of productivity here by multiple people working together very well.
Also, the genius cliche is kind of, it's annoying you because the art market and the art world is expecting a genius, one person that is the artist. And they don't want to see a group of people because then the image of the genius is not working anymore. And so that's a bad thing, but actually although the genius cliche also sometimes helps you because it gives you freedom. Because once you have that image of a genius, you can do whatever you want, and that's your goal. That's the best thing you can get as an artist, to just like do what you want and people throw money at you and you just go crazy. And that's the freedom that's a big goal, because I think that's about being an artist, creating a lot of freedom around you, and then maybe do stupid things.
But the experience of the pre-ars Electronica in general, the last few years, let's say 5 to 10 years, have shown a growing amount of, I would even say, art teams that would summarize around or come together around tools that they are using. Like the Open Framework group is a totally independent art scene that groups together in different, so to say, team members for an art piece, for an expression, for a project that they want to run. And there's open flowing art groups that are not really constantly the same members over years. This is a growing, it's happening more and more often in the recent years. And on the other hand, the single artist, as the genius, so to speak, working alone in his chamber, waiting for the apple to fall on his head, is really going down. So it's becoming more and more a cliche, even though the market, as you say, the art market, especially in the contemporary art, is focusing very, very strongly on big names.
Gentlemen.
Thank you. And the artist Julius from Bismarck just mentioned that once you have the image of a genius, basically regardless whether you are one or not, you can do whatever you want and you find money thrown at you. I wonder whether a parallel could be drawn here to what CERN does. Clearly, by now, it does have the collective image of a genius, and would that mean that there is a parallel of these two worlds, because now CERN can do in research whatever it wants to do and will have the means thrown at it?
I think... I personally think that, what struck me coming here at CERN is that fundamental science is as much under threat as arts in terms of funding. So, and that struck me very, very strongly, because we're so driven by a very product application oriented universe with short-term fixes and short-term products. That actually, if only that were true.
Yeah, I have a different sort of angle on that question, is that we always like to hero worship. It's some ingrained in our DNA, I think, to do that. And there are some people who are extraordinary in the science field that I really look up to, that have abilities that are scary, almost alien, their abilities. But they can't do it alone. It's impossible. And this is all such a joint adventure. And in the discovery of the Higgs boson, or the Higgs boson-like object, there's so many elements that come together on that. There's the geniuses that thought of the Higgs boson. There's the geniuses that understood how to make this accelerator work. There's the genius who understood how to make the tram go up that hill from Meran to CERN. It's a serious comment that it's a societal thing that we have the efficiency and the infrastructure and the competence and genius all around us to make this happen. And so even though I also participate in hero worship, just like everybody else, I can see firsthand in the science business, at least, how much of a collective effort it all is.
So, without further ado, what I would say is this residency, this is the formal end of the residency, but as I say, it's really actually the beginning. Absolutely, it's the beginning. And as Julius has said, he's got a notebook full of ideas, which you will just see in the next 10 years spilling out, and they will have been generated from CERN. So even though this residency is formally ended, the ideas generation will continue, and he will always be part of us. So, be welcome back here. Anyway, now's a really great time to have some refreshments and come up and talk to any of us individually or together, collectively, and ask us anything. Okay, so thank you very much for coming. And what I would say, we're going to be moving some chairs, so don't be disgruntled by a bit of sound. We just need to give you some more space so you can interact with each other. So thank you.